Hi, my name's Taylor, and in today's video we're going to be taking a look at the Arduino-powered sequential LED shift light kit by Chippernut. Chippernut provides these open-sourced electronics kits for automotive applications. This one is a do-it-yourself kit, so it comes as a printed circuit board, an Arduino microcontroller, and about 27 discrete components for you to solder up yourself. And in today's video I'm going to document assembling my kit and bench testing it with an additional Arduino Nano running an RPM simulator program, again from Chippernut. So why would you need a sequential LED shift light? Well, for me, when I was doing my last autocross event, in a couple of my runs, I hit red line. It actually went all the way to fuel cut, which is generally something I don't want to do on a 1986 vehicle. So this shift light will be able to flash at me to alert me that I need to change gear before I reach that red line fuel cut area, which is hard on an engine. Since I haven't seen much content on assembling this kit, I thought I would document it and show that it's really not as difficult as it may seem looking at it as your first electronics project. In the next video, my plan is to integrate this system into a custom 3D printed housing that will also house a rear view camera and install it into the vehicle. So stay tuned for that. Now let's break out the soldering iron and get to assembling this kit. So aside from the electronics kit, which I've put here on the table, let's go over what else you're going to need to assemble the kit. You're going to need a soldering iron. You're going to need some electronic solder. It's a good idea to have some solder wick on hand in case you bridge some connections or need to remove solder if you made a mistake. You'll need a pair of flush cut cutters. You can strip wire with these as well, but it does make life a little bit easier if you have a set of wire strippers. It's a good idea to have a vise to hold the board in place while you're working on it. And lastly, you'll need the ability to bring up the instruction manual off of Chippernut's website. Now to get started, I'm going to plug in the soldering iron and let it start heating up. Already gone through the parts list and make sure that I have everything here that I need. And we're going to begin by installing the resistors. The manual shows you with some photos exactly what you need to look for on the resistors to identify them and where they go. So it's time to dig out the parts we're going to need and start putting them into the board. So these resistors don't have a polarity, which means it doesn't matter which direction you place them. So we're going to just bend the leads downwards into a U shape and stick it in the board. Now that I've placed the resistors into the board, I'm going to flip the board over and solder it up. There you go, all of the resistors are now soldered in place, and it's time to go through and cut all of the tails off nice and flush to the board. So when you cut them off, make sure that it's nice and flat so it doesn't interfere with any other components that get mounted to the other side of the board. Okay, now all the exposed wires have been trimmed flat to the board. We can move on to the next step. The next step is to install this diode, this really tiny component. I don't know if you can even see it on that camera. Here. This is the diode that we're about to install. The manual calls out in red bold lettering that it matters which way you put this in. A diode is like a one-way check valve, so you need to put it in the right orientation. Luckily, right on the board, where it says D1 for diode 1, there is a line silk-screened, and you just need to match the black band on the diode, which on my case is this side here, with the white line on the circuit board. So just slot it in that way. I'm gonna bend those legs down and slot the diode in the orientation that it says on the board and confirms on the instruction manual there. Now that that's in place, I'm going to solder that one by itself. Next, we're installing this Opto-isolator, little black box. Instructions call out that it's important how this is oriented as well, and it guides you to match the little dot with the white dot on the board. I just bent two of the legs to hold it in place while I go to solder it. Next is the transistors. The transistors are called out in the manual based on their appearance. So the transistor is the black dot with three legs that are straight out, versus the black dot with three legs that have bends to them. That would be a regulator. If you have good eyesight, take a look at the part number, because the part number is called out directly on the board. It is a 3906, and it says 3906 on this component. There are two of them next to each other, and this one takes some odd bending to match the whole layout on the board with how these little pins go in. There's an outline on the board with how the orientation of the transistor goes. Okay, transistors are in place. Next. So now they call up that we need to trim all those pins. This is because the Arduino microcontroller actually lives on the bottom side of the board. You don't want any metal pieces interfering with and shorting out anything on the microcontroller itself. Okay, it says we're ready to put the microcontroller in place, and yes, that section of the board that will be covered by the microcontroller is now fully populated. So the microcontroller goes in from this side, from the back, and it uses the voltage in and the ground pins to orient itself on the back of the board. So you look at where it says VIN and ground, and it goes in this corner. So we're just going to line this guy up and put it in place. And then we're going to use a light to look between the microcontroller and its and those components on the board to make sure nothing is going to short. If I had some Kapton tape, I'd probably put it on these connections just to make sure they can't short. But it shouldn't be a problem as long as you did a good job at trimming down all of these solder joints to be as flush as you can have it. Now let's just slot the microcontroller in and get to soldering. Matching up the ground and VIN pins and putting it all the way down there. Okay, now we have our microcontroller on the board, so now we get to go through and snip all of these pins, all 30 of them. Okay, now we got our microcontroller legs trimmed, so everything else goes in from the top side of the board. So now we're on this diode. Once again, a diode is like a one-way check valve, so it is important which order you put it in. The instructions say to match the white band on the diode with the white line on the board. Manual here does a good job. It shows a picture of it and explains clearly what needs to happen to put it in the right way. Okay, our diode's in place. Trim its leads. Get those out of there. Now we're off to some capacitors. And these we're not talking about the big capacitors you're used to seeing. We're not talking about these big capacitors. We are talking about these little itty bitty capacitors. And while it says on the instructions that these do not have a polarization, so it doesn't matter which direction you put them in, these are two different values. And the way you can tell is how it's written on them in incredibly tiny font. So might have to break out some magnifying glasses or take a picture and zoom in on your phone, but make sure that you put the correct one in the correct place. Renault 4 CSK. So yeah, using your phone to zoom in is definitely helpful, because even I got 20/20 vision and that just looks like a couple of little lines and you can't read it very easily. So just be sure that you have the right one in the right spot based on the manual. So there we go. So now we're moving on to the voltage regulator. This is the thing that looked like a transistor but had pre-bent legs. So instructions say to just match the outline of the transistor with the way it is on the board. The spacing of the pins is already matching the whole spacing on the board, so it should just go right in. There we go. Voltage regulators in place. Now we're going to the larger electrolytic capacitors. I guess at this point in the manual they think you're catching on. It just says put them in. It just tells you that they are polarized and you need to follow the white band towards the negative side on the board. But obviously you also need to match the values. So there's a 1000 microfarad capacitor and a 100 microfarad capacitor, and they're clearly labeled on the board, so should have no problem putting that together. Okay, I just went off on a tangent. So, capacitors. There's two on this board, two large electrolytic capacitors. The 100 microfarad, if you see, whenever you put it in place, it goes all the way down to the board. And you want it down and flat because it's protruding from the board and you want it to be as stable as it can be. If you would do the same thing with the 1000 microfarad capacitor, it, because of the way the leads are, doesn't do that. So you might be tempted to just put it in like that. And will it work? Yes. Will it last? That's to be debated. So I'm going to grab some pliers, some very small pliers, and bend it to get that as close to flat on the board as I can. The reason I'm making a big deal of that is at work there is a device that we have to repair quite frequently because it is a really large capacitor that doesn't get held down very well. So I'm actually going to try bending my leads to make that a little bit better, and then I'm also going to put a dab of hot glue to give it some more stability. Is that necessary? No. If you leave it protruding, you're running the risk that vibration over time will break the lead. I don't know how quickly that might happen. I'm sure it depends on your application, but it'd be a good idea if this whole spacing would match the spacing coming right off of the capacitor. Not knocking Chippernut for that. Maybe it's a different capacitor supplier now, or they've made changes over time, but I'd prefer to have it flush to the board if you can. I bent the bends out of the leads, so let's see how that fits now. Much better. So if you straighten out the little bends that come pre-bent on this capacitor, it does line up pretty well. So just, again, keep them as flush as you can, and if any large component is kind of sticking out from the board, might be a good idea to put some hot glue down after you've put the whole assembly together. Okay, so our electrolytic capacitors are in place. Next is our big old rotary encoder. The terminals on the back of this are keyed, so they can only go in one way. So we got this rotary encoder in place. That's how we make our selections for programming. Now it's time to install all of the headers onto the board, one of which you might not notice at first is on the buck converter. On mine it was already installed. So you'll just have to take it apart and solder on your header. You'll also have the header for the OLED display, which is this orange block, the terminal block for your RPM input, power ground and dimmer, and your 4-wire LED connector. Make sure to get the orientation of your power and LED headers correct. The other headers are symmetrical, so they don't actually matter. And there we go, the board is fully populated and assembled. So, the next steps are take your OLED panel, remove your little screen cover, and slot it into the large orange header. There you go. And plug in your buck converter with PCB facing up towards the OLED. To connect your LED strip, take your cutters and scrape the glue off of the 4 solder pads at the beginning of the LED strip. There's an arrow telling you which direction the data needs to travel. Start by applying solder or tinning your copper pads on the LED strip. Not included with the kit, but highly recommended, is this 3D printed alignment jig for when you drill out the lid to the project box so the rotary encoder can protrude and be adjusted. I wish this was available for purchase, but at least the STL file is available on the website, so you can download it and print it, or potentially use a printing service online. So there you go, a fully assembled Chippernut shift light kit. Now, there's only one thing left to do, which is to test it. So now we want to test the shift light here on the bench before we wire the whole thing up to a car and don't know if it's the car causing a problem or if it's the shift light having a problem. So we need something to give an RPM signal to test with. I don't have an extra engine lying around here, so I'm going to be using another Arduino Nano. The RPM Simulator 2.0 software is available on Chippernut as well. You need to supply your own Arduino Nano, but these are fairly cheap off of Amazon or eBay. And there are plenty of tutorials out there on how to flash them. So you will need to download the software from Chippernut and flash it onto your Arduino Nano. So how we need to hook this up is VIN, voltage in, needs to go to the 12 volt supply that we're going to give both this and the shift light. Ground has to go to both this and the shift light. There has to be ground continuity. And then pin D5 needs to connect to the green wire here that goes to the RPM input of the shift light. To do that, I'm going to solder on little pieces of hookup wire straight to this Arduino board. I don't have any breadboard or jumpers or any of the electronics hobby kits that you would have on if you're doing this kind of thing regularly. So this is probably the simplest way to connect it up. Okay, there we go. So now we have our 3 connections made to this Arduino. We got voltage in, ground, and RPM. So now we're going to connect it up. Okay. Just connected up the RPM. Now to power this all up, we're going to use this battery jump pack. Red to red. And black to black. And there we go. We have our RPM gauge up and running. And our screen here is responding, so we are good to go. So overall, I like the kit. This is my first time assembling a kit like this. I have never populated a board from scratch. I have only ever done repairs on circuit boards. So overall, it's a fairly simple process. The instructions, I feel, are adequate for somebody who's just trying this out as their first electronics project. So overall, I would have no problems recommending this kit to anybody who would want to add a sequential shift light to their car. So I'll put links in the description below if you're interested in picking this up or any of the other pieces that were needed. And I hope you'll stay tuned and join me with integrating this system into this display and installing it into the Porsche 944. If you like this video or you're excited for that next video, please consider subscribing. And I will see you in the next video. Bye.